Last time we were working in section 14.5, we had started this section. This is volume. As we work in this section, calculations for volume are typically easier to do than calculations for surface area because the surface area breaks apart into so many different pieces. All right, so the first thing we're going to take a look at, we had talked real quickly with this table last time, some metric units of volume. We'll talk in a little bit later about what you need to know in terms of remembering for your test. But what we're going to do on this slide over here, let me get back over there, is we're going to do some conversions. So we're going to convert from meters cubed into liters. So if we come back over here, we want to see if we have a conversion between meters and liters. And if we don't, we've got to figure out how we could convert so that we can. So taking a look, and there's often, in fact, like almost always, more than one way to do the conversion. So if you think about it differently than me, that doesn't necessarily mean one of us is wrong, okay? So if we wanted to convert from meters into liters, what would we have to do? There's not, I don't think, an actual one that says this number of meters cubed equals this number of liters. So what are we going to do? What could we do? Okay, we could convert it to centimeters because we do have a relationship between centimeters. Oh, but it says it's between centimeters and milliliters, right? Is there maybe a more, it would work. It is, it's deci. Yeah, the little d is deci. So, yeah, I think maybe it'd be easier to use the second line on this table because it actually already has liters on the right-hand side. The nice thing, too, is that meters into deciliters is actually a shorter conversion than all the way into centiliters. Or centimeters. So I'm going to keep doing that all day today. The liters and meters, I'm going to keep mixing them up in my words. So, all right, so we're going to take the 4.6 meters cubed, and I want to turn it into decimeters. Okay, so normally meters into decimeters, what would I do? Just not cubing anything, just meters into decimeters. Move it over one, and Emma's already doing it this way to the right. Yes, move it one to the right. So this 4.6 will become 46, right? So we move it one to the right, but this is cubed, so we're going to move it 3 to the right. We're going to do it 3 times. So this is 4600 decimeters cubed.
How do you know if it's decimeters or decameters?
I don't think any of our conversions actually use decameters, so they're just using deci. I think what they do, and I might be wrong on this, but I think when they do it, they use like a DA for decameters or something. There's something like that. It's been a while since I've seen them used that way, but I'm pretty sure that's what they use, is they use a DA. All right, so this one is 4,600 decimeters now. And if we take a look back over here at this table, it says that if I have 1 decimeter, it's the same thing as 1 liter, right? So it's a one-to-one correspondence. All I have to do is to change the unit on the end, right? So this is the same as 4,600 liters, because a deciliter, you've got me saying it, Amy. A deciliter is the same. I didn't even say liters. A decimeter cubed is a liter, right? So this is 4,600. All right, next one. Millimeters cubed into decimeters cubed. Oh, that's kind of nice because I don't have to work between liters and meters, right? These are both meters. All right, so how do I go from millimeters, again, ignore the cube for a moment, but how do I go from millimeters into decimeters? How many moves is it? 2 moves, right? It's 2 moves to the left. Everybody with me? 2 moves to the left. And maybe I'll just jot this down on the top. And some of you had said you had never actually heard this one before. So to go from millimeters, which is far right, into decimeters, we would have 2 moves to the left. But we're going to do it cubic conversion. So how many moves to the left are we going to go? 6. It's 3 times as many. So what we previously had was 365. Let me move this over here. And this is where my decimal point is currently. This would be my 3 moves to the left, and then I need to do 3 more. So I would have a decimal point, 3 zeros, and then 365. Decimeters cubed. inches and yards. Well, that's more than just moving decimal points, right? We've got 874 cubic inches. All right, so what's the relationship between inches and yards? Do you remember? If you don't, you can go through feet. It's okay. How many inches are in a foot? 12. And how many feet are in a yard? 3. So it'd be 12 times 3, right? So how many inches are in a yard? 36. So the relationship is 36 inches to 1 yard. But this would only be done if I were converting linear units, and I'm doing volume, right? It's cubic units, so I have to do it 3 times. You can either write this down next to it, 1 yard is 36 inches 3 times, or you can cube this, right? Because that's the same thing as multiplying by it 3 times. That will remove my cubic inches here. And what my resulting value needs to be then is you can grab your calculator. You're going to do 874 divided by 36 cubed. This answer ends up being quite small. Most of the time I tell you that 2 decimal points work just fine. This one feels funny to leave it at 2 decimal points, so we'll go ahead and write down 3 or 4 just to make sense of it a little bit better. What do you get if you do, we'll do 3. What do you do if you do 3 decimal places? So 0 is why I don't like the first number very much. 1 9?
0 1 9, yeah.
Yeah? Okay. So this is 0.019 cubic yards. Not very much, right? All right, 36 gallons into cubic feet. So I think that's going to require us to go back to a previous slide somewhere because I don't think that's on the one right before. So let's see. How far back? Oh, just 2 more back before the gallons guy. So 1 more before the gallon guy. All right, so this one talked about gallons and, what did it say? Gallons and cubic feet. So the only relationship here with gallons on the left is here, and this gallons puts it into cubic inches. So it's not exactly where we want to be, but we can work with it, right? Can we do that? So our relationship is that 1 gallon is 231 cubic inches. So we started out with 37 gallons, and we know that 1 gallon is 231 cubic inches. And then I don't want things in inches, I want them in feet. So what's the relationship, what is the numerical relationship that I need to write down in front of feet and inches? 1 foot, 12 inches. And then I'll cube this because I need it to be inches cubed to cancel, right? So the inches cubed will cancel, my gallons are canceling. So computationally, what do I have to put in my calculator? Well, 37 times 231, that's my numerator, and then divided by 12 cubed. Don't forget to cube the 12. It's an easy thing to forget to do. Don't forget that part. What do you get for your cubic feet? Again, 2 decimal places is normally what we'll go with unless there's a reason not to. So what do you have for 2 decimal places? Did you have one, Skylar? What was it? That's what I have too. Good. Does it look okay, guys? Oh, and the last one, cups and inches. Inches cubed. Okay. So we've got cups. The only place I've got cups is right here. On the left, anyway. The only place I have inches cubed is right here. On the right. What am I going to do on this? I mean, what do you suggest?
Fluid ounces first,
Okay.
and then go.
Fluid ounces to gallons,
Yeah.
and then gallon to inches cubed.
Okay, hang on. Let me write down what you're saying. What suggest again, Amy? What did you say?
Go from cup to fluid
Do we have that relationship written on here? Fluid
Yeah,
ounces to
bottom.
gallons?
Yep, and then gallons to
Oh.
inches cubed.
I think there's probably a shortcut.
Could you do cup to pint, pint to quart, and quart to inches?
I would actually go straight from cups to gallons. And I'd use our guy over here to do it. So let's look at our guy. How many cups are in a gallon? He's gallon guy, so he's already 1 gallon. It's 16. There's 16 cups in a gallon. So when you think gallon of milk, if you drink 1 cup a day, that should last you 16 days. You probably drink more than 1 cup when you dump it on your cereal. And less if you use it in your coffee. All right, so let's take a look. 97 cups. To talk about what you guys were suggesting, though, it would work, Elena and Amy. Those things are fine. We can do it that way. I think we can just shortcut one of the pieces so that we have a little bit less converting to do.
16.
It's 16. Yeah, so it is 16 cups. In 1 gallon. And then we have this relationship that we just had from the previous, or maybe the previous problem that said 1 gallon is the same thing as 231 cubic inches. All right, so the units are canceling just fine. Cups, gallons. I've got my inches cubed. The answer would simply be the 97 times the 231, and then that would be then divided by the 16. This is a large number on this one. 1,440?
No,
Four, so like, okay, so 1,400 like that?
Yes.
Okay, and then what? 4 5? I have 4 4. That's okay. Just checking. I guess it's not our largest answer on the screen, but it is fairly large. All right, any questions on that one? Okay, conversions, man. We can convert anything and everything, it seems like, right? All right, so let's talk a little bit about some volumes then. Volume formulas. The volume of a right rectangular prism. Length times width times height. Oh my goodness, is that not an easier formula than 2WH plus 2HL plus 2WL or whatever it was? Yeah, this is a lot easier to work with, right? Yeah, so we have our length times width times our height. We actually saw a picture last time of how this sort of plays out, and it was the Rubik's Cube, right? We found one piece of the area, length times width, let's say. That's the bottom of it. And then we have that bottom area, there's 9 plus another 9 plus another 9. Right? We end up multiplying by 3 because it's 3 layers thick. So that's a justification on where that formula is coming from. Volume of a right or oblique prism. Okay, so oblique just means slanted, remember. Okay, that's all oblique. I'm sorry. Yeah, I said that right. Oblique just means slanted. Right is going to be the straight up and down, you know, so the leaning is the leaning tower Pisa. Volume equals base times height. Now this is capital B. We've seen this before. When they do capital B, what do they mean? The what? The area of the base. And the reason they present this like this is because they want you to recognize that it doesn't matter what kind of a prism it is. If you have a hexagon on bottom, great. You just find the area of the hexagon and then you multiply it by the height. If you've got a triangle on bottom, great. Find the area of the triangle, multiply by the height. So it works for any base itself. And then the h is the height of the prism. Now notice it is the actual height. So if the object is an oblique one and it's slanted, you need the altitude height, right? Not the slant height. We're not talking about slant height here. All right, cylinders are so similar now. The formula for cylinder, oh, I'm sorry, pyramids and cylinders. Did I skip one?
Yeah.
Oh, I'm missing a slide. Fabulous. Okay. Well, I don't have the slide, so let me go through it with you. Let me see if I'll code it as blank slide at the back. Oh, you know what? I've got a workspace slide. We'll do it right here. Okay, so for the volume of a cylinder, you have that the volume equals pi r squared times h. Here's my circular cylinder. The previous page had a volume for a prism that looked like this, didn't it? Isn't this the same formula? Yeah, it should be. It is. The base is simply a circle, and the area of a circle is pi r squared. So this is the B from the previous slide. So this formula actually, I'm not going to go back to it now because it's several slides back, but the formula that we had for the prism actually works for cylinders too. It's just that cylinders have a nice closed, pretty other formula that we can simplify it to working with called pi r squared. And then that says a volume of a right circular cylinder, and then we've got the volume of the cylinder below. I guess I just jumped to the gun, didn't I? R is the radius. These are just two formulas for it. Fantastic. Man, I'm so on top of it. Isn't that wonderful? Yay. I don't have a slide, but we made it work. Okay. Pyramids and cones. Okay, pyramids and cones are also very, very similar. All right, so cylinders' volumes and prisms' volumes are the same formula. It's the area of the base times the height. Well, you do the same thing when you do the cones and the why am I blanking? Pyramids, thank you. When you do the cones and the pyramids, is that it's the same thing. It's the base times the height, and it's just 1/3 of it. Okay?
Why is it 1/3? Where is that coming from?
You would ask, Elena.
It just is. That's what it is.
It has to do with how it's being cut apart, but I don't have a justification for you in terms of like a picture or anything like that. The pieces that are being cut out, I think we can probably do it with a right pyramid probably pretty easily. If you think about taking each of the 4 sides that you've cut out of it and sort of adding it back on, each of the 2 of the, no, never mind, that's not going to work. I was not thinking right. I'm going to stop. I'll bet that it's justified in your book, but I don't remember the justification for the 1/3. Yeah. And then the cylinder is, the circular cone is the same thing. And you're using the base and the height. And of course, this right here, as we just talked about, is the base from the previous information. Okay, I think we have one more sphere. The volume of a sphere, well, the area of a surface area of the sphere was 4 pi r squared, right? The volume of the sphere is 4/3 pi r squared. I'm sorry, pi r cubed. 4/3 pi r cubed. So we've got an example now to work with in these. This says to find the volume of the ice cream cone. We're assuming that it's like filled with ice cream, right? Yeah. So it's not hollow space inside, but we're looking for the space that this takes up. All right, so volume of the ice cream cone. There's 2 pieces I'm going to have to find, though, because this isn't exactly one of the images that we already have. What am I going to have to find the volume of?
The sphere.
Okay, and it's actually a hemisphere, right? I need the volume of a hemisphere. What else am I going to need the volume of? A cone. And you know what the amazing thing is on this? The cone's volume is exactly the same whether the cone has a top on it or not. I always had to be careful when I was doing surface area. Remember me asking as we were working on the other questions is, are they including the bottom of the shape? Right? We don't have to worry about that because volume, it doesn't matter. There's no volume on the single surface itself. So, all right, let's do the cone's hemisphere part first. So the hemisphere is the volume of the sphere up here. And so it's 4/3 pi r cubed if it's a whole sphere. So what are we going to do for a hemisphere? Divided by 2. So what would it be? 2/3, right? If you've got 4/3 and you divide by 2, you get 2/3 pi. And then what is r in this situation? 4. And that's cubed. So we have 4 cubed times 2. What does that give me? What's 4 cubed? 64. What's 64 times 2? Stretching your brain today. 128. So this is 128 pi over, what was my value? 3. We'll put units on our answer at the very end. So we're still working in the middle of this. So I'm not going to worry with the units at the moment. How about the volume of a cone? How do I find the volume for a cone?
Base times height.
Yeah, and the base is a circle, so it's pi r squared, right? Times the height. So 1/3 pi. R is 4, I just did that a minute ago. 4 squared. What's my height? 8. So we need 4 squared, that's 16. What's 16 times 8? Yeah, it's 128. So this happens to be 128 over 3 as well. So can we add them together? Well, of course we can. What's 128 plus 128? It is 256 pi over 3. What would my units be?
Centimeters cubed.
Good, centimeters cubed. And if I wanted a decimal approximation, depending on how the question was worded, could I do that? Sure. Take 256 times pi and divide by 3 and tell me approximately what do you get. Nice. Cubic centimeters. All right. There's my cone. All right, we're going to see another shape that we've seen before today. This is similar. This one is not assumed or needed to be assumed to be isosceles. It's not a necessary feature. So, find the volume of the right triangular prism. So take just a second, try that one, and then once you're done with that one, it says a standard straight drinking straw is 25 centimeters long, 4 millimeters in diameter. How much liquid can be held in the straw at one time? One thing to be careful of is to notice this is in centimeters and this is in millimeters, so you're going to have to get those in the same units before you start working too far into the problem. Okay, so take a couple minutes, take a look at 1 and 2 here, and then we'll come back together and make sure that everybody has the same answers. Okay, so I hear lots of good conversations going on. Good comment that I just heard Elena trying to clarify is how do we decide what the base is for the shape that we're given? I mean, it's a rectangular prism. I mean, not rectangular, but there's triangles in it, there's rectangles in it. How do we decide what the base is when we're given that shape there? Yeah, the prism has sides that are always the rectangles. So those sides that are rectangles are the lateral faces of your prism, which means the triangles are actually the top and the bottom. Okay, so when we look at finding the area of the base is the area of the triangles. So we have the base times the height, but the base, this is volume, the base is actually 1/2 the base times the height of my triangle. We'll call this one H1 because it's a different height we're talking about here. Not to confuse the issue, but I kind of did in that problem, I'm sorry. But the base and the height of my triangle, what are the base and the height of my triangle? They're 6 and 6. And then the height of the rectangular prism itself, I keep saying rectangular, this one's triangular. The height of the triangular prism itself is 12. So you need 6 times 6 times 6, actually. What do you get?
216 centimeters cubed.
Good. All right, so for the sake of us doing the problem together the same way, do you want to turn things into centimeters or into millimeters for the next problem? Centimeters? Okay. If you did it the other way, it's okay. We'll just convert at the end to make sure everybody has the same answers. So that means that I would change the 4 into centimeters, which would give me 0.4, right? Correct? Okay. If you did it in centimeters, I'm not asking you to change it. I mean, if you did it in millimeters, just hold tight. Okay, this is the screen I used a minute ago. All right, so we need the volume of a cylinder. What is the volume of a cylinder? Well, it's really base times height, right? And the base of a cylinder is a circle, which is pi r squared. What's r in this problem? That's the point, what'd you say? 2? The 0.2, because it was 0.4 was the diameter. Is that what I said? Yeah. And then the height? 25. Okay, so what is 0.2 squared? It's not 0.4, it's 0.04, right? 0.04 pi. And then, oops, then I was supposed to multiply by 25. We'll do that next. What's 0.04 times 25? 1. Was it 1, really? Wow, that's nice, isn't it? So is this just pi? Pi what? Centimeters cubed. Okay, good. Centimeters cubed. If you did this in millimeters, what would you have gotten, or what did you get? Did anybody do it in millimeters? It would actually be 1,000. Why would it be 1,000?
Because it's cubed.
Yeah, because centimeters and millimeters are 1 decimal point apart, and so then we'd multiply that 1 times 3, right? So it'd be 3 decimal points apart, so you get 1,000 millimeters. I'm sorry, I left my pi out. We need a pi in there too. 1,000 pi millimeters. There we go. All right, some other conversions. Mass and weight, some differences. Mass. Mass is the amount of the amount of matter an object contains. Weight is how much force gravity exerts on an object. So if anybody's ever been to the Science Museum, they have the scales where you can weigh yourself in what you weigh on the moon, right? They give you your pounds on Earth, pounds on the moon. It changes because pound is a weight measurement, but kilograms is a mass measurement. All right, so the pounds, it says the English unit for weight is the pound, the ounce, and the ton. So 1 pound is 16 ounces. You should know that probably at some point for measuring purposes. Or maybe you want to see, you've heard people's weights for their children when they're born. Occasionally you'll hear those. So you get like 7 pounds, 14 ounces, stuff like that. And then an English ton is 2,000 pounds. And occasionally you'll come across bridges that will say weight of vehicle not to exceed 2 tons or something like that. So you'll see tons mentioned there. This is the English ton, and it's T-O-N. Okay? We're going to have 2 tons here in a minute, a different ton. This is the English ton. Right? And then the metric unit for mass is actually based on the gram. So here is the second ton. The second ton is a metric ton. And a metric ton is 1,000 kilograms. So you know how you go from milligrams to grams and it's 1,000, and then you go from grams to kilograms and it's 1,000. Well, from kilograms to tons, metric tons is 1,000. So 1,000 higher than that. All of these are the same ones you've seen before. Oh, and look right there. I did remember it right, Amy. It's DAG for deca. Yep. All right, so these are all of the conversion amounts. These are the same things that we've been working with King Henry died by drinking chocolate milk stuff. Nothing new except for the metric ton part of it, okay? All right, so the first thing we're going to do is we're going to do some conversions of volume, capacity, and mass. So there are relationships, and they're at the very top of the screen. 1 cubic centimeter, which is the same as 1 millimeter of water, equals 1 gram. They're all ones. That's awfully friendly, right? Which means, in essence, I can sort of just change out the unit because they all have the same measurement. 1 decimeters cubed is 1 liter, which is equal to 1 kilogram. And notice it says of water. Why does that matter? Not all liquids are the same. as evidenced by probably what took place in the Oval last night, I'm guessing. Right? There's a reason that milk is used when water's not. Water wouldn't produce the same result, right? Because the weight of it is different. Wasn't that timed just perfectly? I mean, like, come on, that was a good... They must have known we were going to be talking about this today to have planned that last night. So, was it last night or 2 nights ago?
No.
2 nights ago? Last night? Okay, it was last night. I saw a couple pictures on Facebook. They were fabulous. All right, so we're going to convert 3,689 grams into metric tons. And the only conversion that we have in terms of metric tons has to do with kilograms, right? The very top one converts grams and kilograms and metric tons together. Oh, I guess it actually did do the grams itself right there. I didn't see that one first. Yeah. All right, so it's 1 million grams. It's 6 decimal points different, correct? So if I'm going to go from 3,689 grams to metric tons, I need to move the decimal 6 decimal locations. Which way, left or right? Left. So I've already going to have 4 if I move it to here. So I need 2 more. So this is 2 zeros, and then 3, 6, 8, 9, and tons, metric tons, is a T. English tons is a TON. Just for fun. Okay? All right, the next 2 are a little bit more interesting. Complete the following relationships. 1 cubic meter of water has a capacity of 1 something else. And it says capacity. Capacity's unit is this one right here. It's the liter unit in the middle. So they're wanting to turn it into liters or milliliters or kiloliters or something. And so we don't really know what we want until we can get it to be the number 1. So we're going to do a conversion and we'll see what happens. This is 1 cubic meter. Well, over here, where were they? Oh, no, I had it was on the top of the screen. I'm sorry. Up here we have cubic conversions into liters. Hang on, this is what I wanted to do. But we don't have meters cubed. We have centimeters cubed and we have decimeters cubed. Which one's closer to the meters value, centimeters or decimeters? Decimeters. So that one's actually easier to work with. So if I have, this was 1 cubic meter. Oops, it was right there. How would I get this to become decimeters cubed? It's 1 decimal different, but cubed, right? So I'm going to make it 3 times. So this is going to be 1,000 decimeters cubed. And then the cool thing about this conversion is that it tells me that decimeters cubed is the same as liters is the same as kilograms. Right? So the liters part is the part that I'm on because it's talking about capacity. So this is the same as 1,000 liters. But what I'm asked for is what is this in terms of the number 1? If I have 1,000 liters, that's 1 what? Kiloliter. The relationship between liters and kiloliters is 1,000. So it'd be 1 kiloliter. Okay. Now, we can use almost the same information, can't we? Because we're going to go into mass now. And mass turns things into the gram or kilogram units that are over here on the right. So I already had this in terms of decimeters cubed right here. I can use that information and turn it into then the kilograms. This is equal to 1,000 kilograms. Whoops, I left a 0 off. But I want it to be 1 of something else. It's tons, metric tons, right? That is not a decimal point. That's part of the last period at the end of the line. So this is 1 ton. 1,000 kilograms is 1 ton. All right, let's take a look at this one together.
Sorry, would you mind going back to that real quick?
Yep.
So sorry.
All right, we have a pool, Olympic-sized pool. It's the shape of a right rectangular prism. It is 50 meters by 25 meters, and it's 2 meters deep. So this is like the kind of pool that you would play volleyball in or whatever, because it's a consistent with our depth the whole way kind of deal, okay? So we have this rectangular prism. Not that you have to draw it, but this is what we've got. And it's 50 by 25 by 2, and they are all the same units, so we don't need to do any conversions. And it says, how many liters of volume does it hold? Well, these are all in meters, so the first thing we're going to figure out is how many cubic meters it holds. So what would I do to find my volume?
That area of the base times the height.
Okay, so that would be 50 times 25 times the height, or in this case, it's almost like depth, which is 2, which will give me 2,500 cubic meters. But the relationships between meters, or between cubic values, and the liters, milliliters kind of things that they're going right here, are all in terms of either centimeters or decimeters. And it's easier to work with decimeters simply because they're closer. So I can take the 2,500 that I have and move the decimal point 3 places. This gives me decimeters cubed. Let me get my commas in the right place. This is 2,500,000 cubic decimeters. But it wants to know liters. So what's the relationship between decimeters cubed and liters? 1 to 1. So this is 2,500,000 liters. All right, we are going to fly through temperature. You guys ready? Fly. Okay. The base English unit for temperature is called the degree. It's degrees Fahrenheit is what we're comfortable and used to using. Fahrenheit scale divides the temperature range from the freezing point of water is 32 degrees to the boiling point of water, which is 212 degrees. And it divides it into 180 equal parts. The base metric unit is, in metrics, is degrees Celsius. The Celsius scale divides the temperature range from 0 to 100 into 100 equal parts. And then you may have heard of Kelvin before, typically used in scientific measurements, because it has an absolute 0. It is the value below which you do not have temperature. I mean, there's no recordable value. The lowest point is 0, is actually approximately 273 degrees Celsius. Okay, so it says the absolute 0 is 273. I already said that one is 373. Then is for the boiling point. So you could go down to 273 negative on the Celsius scale before you get to absolute 0. It's kind of crazy. This is a fabulous sort of a picture for you to think about in terms of common values. So when we talked about that 37, I think ours was 38. That's our body temperature approximately. It's 100 degrees outside, so we're not going to run the half marathon and we're not going to build a snowman. But also if the temperature were 10 degrees, we wouldn't go swimming, right? Yes. And if it were like 50 degrees, we might have to find some air conditioning very, very soon. All right. There are 2 conversions here that go between Celsius and Fahrenheit. You've seen these before. Let's do one real quick from 40 degrees Celsius into Fahrenheit. You can use either formula. Doesn't matter, they're the same formula, just manipulated. But if they're giving you Celsius, the formula that's easiest to use is this one because the Celsius is on this side with all the other values that you can calculate all over there, and then it gives you Fahrenheit when you're done. So this is Fahrenheit equals 9/5 times 40 plus 32 degrees. So what is 9 over 5 times 40? It is 72. Plus my 32 would give me 104. And we make sure we use our units of degrees Fahrenheit on the end to clarify where we are.